Hello friends, our today's topic is Introduction to Linear Algebra. First we will write down the name. Introduction. Okay, in this topic we will cover what is the need of this subject. Okay, first we will see that need. Second we will cover the important terms. Okay, important terms used in this subject and how to represent vectors into matrix. Okay, first need. Why do we need this subject? Suppose I will give you two equations and two unknowns and ask for the solution. You can easily solve it. But what about if I will give you 1000 number of equations, 2 versus 1000 number of equations? How can you solve it? Definitely we cannot solve it manually. We need a computer to solve that. Okay, and computer works on algorithm, and here the need of this subject comes. And this subject provides us an algorithm to solve it. Okay, the role of vectors in this subject are also very important. Suppose I will give you two number of vectors. First we will clear this. Okay, two vectors into 3 dimension. Sorry. Okay, how can you represent these two vectors into the matrix form? First take two vectors. Suppose V will be the 1, 2, 3 and another vector will be W 1, 3, 4. First we will see how these two vectors are into this space. Okay, suppose V somewhere will be the here, W somewhere will be the here. Let's give a name VW, and these two vectors form a plane into the three-dimensional space. Okay, why I am saying that these two vectors into the three-dimensional space? Okay, just see the parameters here. I mean coordinates represented here. This one is I, this one is represented by I, this one is J coordinate, this one is K coordinate. That's why I am saying that these two vectors are into the three-dimensional space. Now we have to represent these two vectors into the matrix form. Okay, this is a very simple. Just write down matrix form. Okay, let's give a name to that matrix A. Okay, matrix represented into the that rectangle form. First write down the first vector directly into the first column. Okay, 1, 2, 3. Similarly, second vector into the second column, 1, 3, 4. That much simple is this. Okay, This is a nothing but m by n, means m is nothing but number of rows, which are 3, by n means 2. Okay, now we will write down m number of rows, nothing but number of dimensions. Here it is a 3. Okay, and number of column n is nothing but number of column, nothing but number of vectors. Here that is 2. I think now you get that how to represent vectors into the matrix form. Okay, simply number of vectors are nothing but number of column of that matrix. Write down first vector into the first column, second into the second column, similarly remaining. Next we will see some basic terms which will be very useful into the future topic. These are the base of this subject, linear algebra. Okay, we will clear this. Here we'll write down basic terms. I will start with the example. This subject is very easy with the example. Consider matrix B represented by 1, 2, 3, 1, 5, 6. Okay, and these two columns are nothing but vectors. Write down just vectors. V is equal to 1, 2, 3. W is equal to 1, 3, 6. Okay, these are nothing but vectors. I am representing these vectors into the three-dimensional space. And suppose I will ask linear combination of about these two vectors. Okay, linear combination. How can we represent it? Suppose I will multiply by scalar. C and D are nothing but scalar. Suppose I will tell you that C times V plus D times W will be the B. This is nothing but a linear combination of these two vectors. And I will ask where this new vector B, it gives us a new vector B, where this new vector B will lie. Here I will write down the question, where B will lie. Okay, simply I have to tell you that this new vector B will lie within the same plane as that of V and W. That means here it may be lie here or there anywhere, but into this same plane. This is a very basic and important thing that I am telling you. The new vector B will lie into this same plane, which is formed by basis vectors. Which are these two basic vector? Nothing but v and w. Okay, this is a very basic term and which is very useful in our future topics. Next we will see a column space, row space and rank of the matrix. Okay, we will first clear this. Clear. Okay, I already told you that this subject is very simple with the example. So I am going to take an example. Suppose C will be the matrix. First 1 1 1. Okay, second will be 2 2 2 2, and third will be let 4 5 6. This is nothing but 3 by 3 matrix. First we will get an information from this matrix. This matrix represents 3 number of rows and 3 number of columns, which means it represents 3 vectors into the 3-dimensional space. But I have to tell you that if you see closely, the second column is nothing but multiple of the first column. Okay, that means it nothing but a linear combination of the first column, means first vector. Okay, here I will write down second column is linear combination of first. Okay, that means it is not an independent second vector, or second column is not an independent vector. That means is nothing but a first one. It is a multiple of first one. We can, if this condition are present, we have to use an elimination. Okay, how can we eliminate this second column? Simply second column or first column, we can eliminate any one of this. Okay, if you multiply first one with the 2, okay, then what will get? 2 2 2 2 2 2 and 4 5 6. And if we subtract second one from first one, we will get 2 2 2 4 5 6. Okay, we get that. And what does this new matrix will represent? This is nothing but a 2 number of vectors into the 3-dimensional space. Okay, this may be V and this will be W. Okay, now this is a clear. I have to tell you that second or first one vector will lie within the same plane. Okay, because this is nothing but a multiple of second column, or we can say a linear combination, and we already say that the linear combination of the vectors will lie into the same plane as that of the basis plane formed by that basis vectors. Okay, I think this one is clear. Next thing, We will first clear this. Column space. What do you mean by column space? We already say that column space, but we have not given a name to that term. एक minute. Okay, just a minute. Okay. So I told you that linear combination like C times V plus D times W is nothing but a new vector B. But this we can form infinite number of B or new vectors by just taking an infinite combinations of these two V and W. Okay, we can take infinite scalars to form a linear combination, and that all the new vector B will lie into the same plane as that of basis vector, here, anywhere. These are nothing but infinite number of new vectors we can form from that two basis vectors, and all of that combinations which are present into that space we called it as a column space. Okay, column space is nothing but all, I will say, space which includes all the combinations, I mean linear combinations, all the combinations of the vectors. Okay, vectors or columns of matrix. Next term is a row space. This term is also very simple, but this is nothing but all the combination of the rows. Okay, similarly space which includes combinations of rows. That much simple, my friend. We cleared column space and row space. These are nothing but all the combination space which includes all the combinations of the column or rows. Okay, next we'll see rank of the matrix into the next window. First we'll clear this. Write down the name of topic, rank of matrix. This is nothing but I will directly write down the name, definition of this term. Okay, number of independent columns or rows, okay, is nothing but a rank of the matrix. We previously say that we have seen that matrix B was this 1 1 1 2 2 2 3 4 6. Okay, something like that. And we had simplified this matrix by elimination, means eliminating gives us the new matrix 1 1 1 or 2, sorry, 2 2 2 3 4 6. Okay, what does this second matrix represents? Simply two number of independent columns. That means its rank is nothing but 2. Okay, from this matrix B we have seen that by after applying elimination method we get two number of independent columns. That's why the rank of this matrix is nothing but 2. We have cleared this subject. Okay, I mean this topic. We have studied how to represent vectors into the matrix and some important terms such as linear combination of the vectors, second row space, column space, and rank of the matrix. This is the surface information of this subject. We have discussed that much important terms, and we will discuss these terms into detail in our future lecture. Okay, thank you. See you into the next lecture. Hello friends, our today's